All right, guys, more geometrics today, but kind of unusual. Got to really read this to see what I'm talking about when I say unusual. It says finding sums of infinite geometric series. So we're going to find the sum of something, a series that like never ends, which when you really think about that, yeah, let's go. Here's an example. I want to show you how this works and what we're going to do. This is 1 plus 1/2 plus 1/4 plus 1/8. Okay, so R here is 1/2. They're multiplying by 1/2, 1/2, 1/2, 1/2, 1/2. So it is geometric. Now watch what happens when I start adding these terms together. If I add the first two, I get 1.5. If I combine the 1/4 with that, just trust me, it becomes 1 3/4. If I combine the 1/8 with that, I get 1 7/8. If I combine the 1/16 with that, I get 15. You see the pattern here? If I do the 1/32 with that, I get 1 31 over 32. So what's happening here, my fraction part and my whole number is getting closer and closer and closer to 2. Now, obviously the next one's going to be 1 and 63 over 64. Still not quite 2, but it's getting closer and closer. What's happening is this thing goes on forever. It gets, you ready for this, infinitely close to 2. And because it's infinitely close to 2, we're just going to say, okay, the sum's 2. All right, because it gets infinitely close to 2. The longer it goes, the closer to it gets. Because it goes forever, it's 2. That's kind of the logic there. I want to kind of at least explain to you what's going on, because once I show you the formula, it's very easy to work the problems out today, but I kind of want you to know what you're doing and why it works. Okay, if we have an infinite geometric series, and we know the first term and R, this is all we have to do. It's A1 over 1 minus R. But there's one catch, and the catch is this. R, the absolute value of R has to be less than 1. So really and truly what I'm saying is R has to be a fraction less than 1. It could be negative, that's okay, but it's got to be a fraction less than 1. If R is greater than 1, it has no sum. Okay, there's not a sum, and you're going to have some problems tomorrow where you can't do it. Some of you are going to do it anyway, but you can't, because the formula will still give you an answer. But you have to realize, oh, my R is too big. I can't do it. Okay, so be careful. All right, I'm going to show you a couple. Find the sum of the infinite geometric series. Don't do it until you check your R. You got to have R anyway. Might as well see what's happening. Remember the way you found R from yesterday? You put the second number over the first number, so you get negative 3/4 over 1, which is negative 3/4. Now, because that's a fraction, less than 1, the absolute value is less than 1, we're good to go. So I'm going to say the sum of the infinite sequence is the first number, which is 1, first term, over 1 minus R, which is negative 3/4. Now, 1 minus negative 3/4 is really positive 3/4. And if you do that division right there, 1 divided by 3/4, you get 4/3. All right, so there's your sum. Now, that's all we're doing. You're going to see sigma. The difference in the sigma you're going to see tomorrow is, look what's on top. Infinity. All right, so that means it's an infinite sequence. The cool thing about this is, remember, all you need is A1 and R. That's all you need. The R is always whatever's raised to the power. So R here is 0.8. Easy to check that one. We're good. It's less than 1, so I can do it. So I'm going to say the sum of infinite is going to be 1 minus 0.8 in my denominator. A1 means first term. Plug in the 1. 1 minus 1 is 0, so it gives me that to the 0 power. Anything to the 0 power is 1, so 5 times 1 is 5. That's the first term. So it's really 5 over 0.2. And 5, you can just punch that in, or you can change it to a fraction, do your division. 5 divided by 0.2 is 25. And there's your infinite sum. All there is to it. Okay, I'm going to show you one more thing that we can do. The one thing extra we're going to do with these today, with these infinite sums, we're going to take repeating decimals like this and change it to a fraction, because a repeating decimal is really an infinite geometric series, because you can write it like this. It's really 0.24 plus 0.0024 plus 0.00024 plus 0.0000024. And I could do that forever. That's enough. That's probably too much. And if you check your R right here and R right here and R right there, it's definitely geometric, because if you put the second number over the first, what you're going to find out is R is 100th or 0.01. That's my R. Just punch it in the calculator. See for yourself. It's 0.01. Okay, now the first term, 0.24. So I'm going to do the same formula. First term over 1 minus R. When I do that, I get 0.24 over 0.99. Now, because they both have two decimals, I'm going to move it two decimal places over on the numerator. 2 decimal places over my denominator, and you get 24/99, which is fine, but the directions did say lowest terms. Make sure. I do know 3 goes into both of these. 3 goes into 24 8 times, and it goes into 99 33 times. So there's my fraction. This is very easy to check. You can take your calculator, punch in 8 divided by 33, and it will say 0.2424242424, until it stops. It runs out of room. So all there is to it today, pretty short and sweet. The problem's not going to be that big a deal tomorrow. Just make sure you check your R. It's all about checking the R. Okay? See you tomorrow.